Hello everyone, I'm Kazuhiro Metani from Okayama University, Japan. Today I'm going to talk about the lecture class for the power electronics that embeds the experiment in the lecture. So let me introduce the presentation. Well, so firstly I want to give the background of my research. As you know, so many electric devices need power conversion circuit from the AC power source. Well, the commercially AC power electricity is given in the form of AC power. But in fact, many electric devices need a low voltage DC power. So we have to put the power converters to transform the AC power into the low voltage DC power. So power electronics is a circuit technologies of power conversions for various industries. In the daily life, it is really common to utilize the AC adapter to change the form of the power. Well, so it is actually the kind of the very popular type of power converters, but it's not restricted to the AC adapter. In very big factories, like a network server, also very big system for the power converters is installed in the system, and also in the EV propulsion system, the very high voltage power conversion circuit is also installed. Well, so necessary quality of performance and performance of power converters are different depending on each product. And power converters is therefore commonly customly designed, so it's different between each product. And also many industries therefore need power electronics engineers to make their power conversion circuit for their products. So because of wide industrial needs for better power converters, power electronics education is especially important in universities and also in companies. Well, so as because power converters itself is a kind of analog circuit, education of power converters have been held like a similar way as education of analog circuit. So they are commonly given lecture classes. In the classes, the teacher shows the circuit schematics, and this operation of the schematics is analyzed using a theoretical circuit operation analysis. Where as for the normal analog circuits, like a signal processing circuit, it is very convenient and it is okay because operating waveforms is the most important things. But as for the power converters, the quality of power converters lies not in overall circuit operating waveforms, but actually even the same circuit schematics, there is a various product. So we have the wide diversity in the product quality, and they differ in volume and heat and noise. So a full lecture class tends to be sufficient to orient the students' attention to the quality of the power converters of these things. It does not appear in the circuit schematics and operating waveforms. Well, so you may think that student experiment can be a possible solution. It may be, but we have to take care because bare circuit board or power converters may not be so safe for the students because many power converters transforms the AC high voltage AC power, and it causes electrical shock if the students touch it to the bare board. And of course, there is some kind of the power converter that handles a very small voltage. Yes, but even a small voltage power converter can cause fire or burning and or even explosion if you test it badly. So therefore, many power converters is packed in a black box for the security issue, but it's not good for the experiment. So power electronics experiment needs special care of security. As a result, the experimental setup appear black boxes to the students. Well, so let me explain about my idea. Well, my idea is how about doing the same thing as Michael Faraday. The Faraday is actually very famous for his electrical achievement, but I rather want to focus on his educational achievement. In education, Faraday is very famous for his Christmas lecture. In this lecture, he uh, collected many youngsters and students around him in a very big teaching room, and he carried out an experiment in front of them and showed the experiment, and also at the same time he gave the lecture based on the experiment. So my idea is how to do the similar things. So I mean the teacher demonstrates experiment during the lecture class of the power electronics. Then the student can watch the teacher's on-site live experiment, and because teacher conducts the experiment himself, security issue can be solved. And teacher demonstrates real circuit after talking his theoretical operations. Then the student can remark discrepancy between the actual and ideal operation that actually matters in the power electronics electronics engineering. And also teacher discusses the experiment result with the students during the class, so the experiment can be flexibly adjusted according to the student question, and discussion may make more active engagement with the students. So it may be very promising. But of course, there is some challenge. So how to demonstrate electrical experiment to the audience? Even Faraday needs to carry out this type of lecture in the topic of the chemistry, because in the chemistry it is very easy to demonstrate the effect, demonstrate the experiment, because in this experiment he showed the fire, smoke, or something like that. It is very visible to the students sitting very far from the teacher. But as for the experiment of the power electronics, it's not so easy things, because teacher needs to show the test circuit, experiment setup, display of digital meters or oscilloscope. It's not so convenient. So my idea is how about using the modern tools for presentation and electrical testing tools, which can enable the teacher to include the experiment in the lecture class. Well, this is the concept of my lecture class structure. So in total, the teaching lecture class have, for example, have 100 minutes, and among them, 80 minutes I give the lecture. Give the talk of the electric circuit of power conversion, and so I discuss about the basic circuit operation, theoretical analysis, and give the lecture on the difference between the idea and the actual circuit, and give the considerations of practical circuit design. And after that, I give the mini experiment session, so demonstrate the experiment about 15 minutes. And after that, I discuss it about the experimental result for 5 minutes with students. So the important part is here, the mini experiment session. In this experiment session, I utilize the projectors and the screens to show up the desktop of the teacher's desk. So I conduct the experiment in the teacher's desk, and the student is located slightly far away from the teacher's desk, as in the normal classroom. But the camera is filming the desktop, and it is connected to the projectors to show up what is going on the teacher's desk. So this is my idea. Okay, so let me share the experience of the actual class design based on this idea. Where I tested this type of idea in the power electronic class in Okayama University, Japan, and it's held from the November to February. I tested 2 times, so I mean in 2021 and 2022. And the students is this lecture is given for the students of the undergraduate course of the 3rd grade, and the number of students is approximately 30 to 40. In total, there is 15 classes, including midterm and final exam, so the net lecture is given in the 13 classes. So in attendance style, in 2021, due to the effect of the COVID-19, this class is held in the hybrid style. But in 2021, I shifted the attendance style to the on-site attendance. So the students gathered in this classroom. This is a picture of the classroom. Okay, so this is the schedule of this subject. There is in total there is 15 classes, but among them there are 2 examinations. And in this examination, we don't have any experiment. And also the first class gives us some kind of guidance of this technical field. So in this guidance, also, I don't give many experiment. But except for these things, almost every teaching classes have mini experiment session. And next, I want to show about the experimental setup for making a presentation of the power conversion circuit experiment. And this is the teacher's desk, and I put the experimental circuit on this desk. And also I put the document camera that takes a picture of the desktop. And as for the electrical experiment, I put the oscilloscope. So the document camera and oscilloscope give the images connected to the laptop and give the image of the desktop, and also the voltage and current waveforms. And the data is collected to the laptop, and it is connected to the projectors via external video terminal to show the students what is going on the teacher's desk. Well, so in this experiment, I take care that everything should be very practical thing, because I want to show what is the practical problems and practical effect or practical quality of the power converters. But at the same time, we have to take care that only the circuit board is designed specially for the lecture class. It's not so practical because I need to make the students can easily comprehend the circuit network. For example, so in the practical power converters, the circuit network is commonly very complicated, and it is very difficult for the students to understand. So in order to solve this problem, I made the circuit board that resembles the circuit schematic. This is an example in a lecture session. This is a very basic style example. In the second class, I explained about the very basic rectification circuit as shown here. The diode, this is a half bridge rectification circuit, and this is full bridge rectification circuit. The important difference lies in the network of the diode. So in this mini experiment, I wanted to make the circuit board that really resemble to the schematics. For this purpose, I purchased the whiteboard and put the copper tape on this and installed in the diode, solder the diode on the copper tape. So this can make really resemble to the circuit network, and student can easily understand what is going on, what kind of test circuit is experimented. Well, so next I want to show the survey results. So firstly, I want to took the student survey results on the educational effect of the mini experiment session. The survey results collected from the 28 students in 2022. In this survey, I asked 5 questions. Mini experiment was effective for education. Observing voltages helped your understanding. Experiment stimulated the interest to the power electronics. Operation of actual circuits helped your understanding of practical applications, and experiment helped to notice the difference between the theory and actual circuits. Yes, so this is the result. The red one is I asked the student to score in 5 degrees, and this is the most positive answer, and the score 1 is the least answer, but there's no so bad scores. But this is the result. As you can see, the students strongly agree the positive effect for watching of actual circuit operation for improving the understanding of power electronics. Well, so again, next I will show you the student survey result of the management of the mini experiment. I asked also 5 questions regarding the management of the mini experiment session. For example, the mini experiment was conducted in a sufficient explanation. About half, 50% answered yes. Whereas the mini experiment was shown in a sufficient image quality. Every time I succeeded to identify circuit network from image on the screen, explanation of experiment was given in a moderate speed. So about one half of the students totally agree with things, but slightly there is also you can find a negative answer to this question. So we need some improvement for demonstrate the clearly demonstration of the experiment. And finally, I asked sufficient time assigned for the mini experiments. Okay, not so many many students answered no. So I think that accurate lecture time scheduling is very important for this type of lecture style for assigning more time to the experiment. In many cases, lecture time can expand and it's cut off the experiment session and it makes the whole experiment very difficult to understand. So we need to have the accurate time scheduling is really, very important. Should be improved in the future. Okay, so finally, I want to give the conclusions. So in the background, the full lecture classes tend to be sufficient to orient the students to attention in the quality of power converters, like a power loss, a volume, and noise, and something like that. So in order to solve this problem, we propose an improved lecture classes for power electronics educations that embeds the experimental mini session in power electronics lecture classes by utilizing modern presentation and circuit testing tools. According to the student survey, the proposed method helped better understanding of power electronics. But nonetheless, it still needs solution in more accurate time scheduling for assigning sufficient time for mini experiment, and also more technological improvement is needed for clear experiment demonstration. These things should be solved in the future education. Okay, so this is all I want to say for you, and thank you for your kind attention.